So this is RDF, Rapid Data Forensics, and what it is it's a set of capabilities where we're showing people how users can interact with various kinds of data to find hypotheses and be able to generate collaborative solutions with other people. And so there's a few different components to it. These two components are not attached to any real data. They're attached to real data, but they're not attached to each other at the moment because they were started before the data lake was created, which is where the data from this one actually comes from. So what we have here is a system for showing the analytic results that came back from a particular issue. It's like, I don't want to use a negative word for this, by the way, so kind of speak it to it positively. Where we have a visualization which shows a classification, whether things are yes or no on something, and then what's called a similarity graph, which shows how they're similar to each other. It doesn't matter that it's this classification and similarity graph. It could be any other kind of visualization. The idea just was to show that there was an output from an analytic and it's getting shown here for the user. And then when you go from the output of the analytic, you go to the next part, which is you're trying to understand the relationship between these assets and what was going on with them. So in this case, when I click on one of them, I can see where that asset was flown. And then the next thing I can do with it is I can then look at the something about what happened to that asset. In this case, what it shows is the events that asset had, and the events that we're showing in this particular case is showing where it flew at different times. So I can see that it flew from Dubai to Glasgow, and then I can go in and look at where the takeoff was. And the reason that we're interested in that is the takeoff is when engines are worked their hardest. And so it's a quick way for a user to say, I was able to get quickly from some analytic information about it to learning about those things. So it's most important is just different visualizations help people understand different things. In this case, all we're doing is we're helping them quickly understand where did it fly and where did it fly for its hardest part. Down here we show, this highlights at the same time, and then so you can understand how much elevation it was gaining during that time. We could have different information here. If you had different questions about the asset, you might have maintenance information there, you might have optimization information, reliability information. It just depends on the kinds of questions that somebody might be asking, how you would build out one of these to help them do their job with it. So then we move over to the other side, which is the asset view. And what's going on here is where this is showing the environment over here that the engine flew in. So here is like kind of a conceptual space, the environment it was showing in. This one is about actually how it was flying, how it was being used. So in this case, what we have is we have some asset information about the model, the aircraft, and the ID for it. Again, the ID is the same as the ID you see here and you see everywhere else. And then you have the parameters. And so the parameters are the data coming off of the engine. And we can look at different data. So here we could look at this PCN 12 and things like that. We look at EGT, which is engine gas temperature. And for the engine gas temperature, what we're doing is we can go in and we can actually look at what kind of responses we're getting for different engines. And so if we look at this one, we can look at the actual parameters coming off the engine, and we can get a closer view here. And what's cool about this whole system, how all the views interact, is that once I select this piece of the signature, then we see how often that signature appears throughout time. And what we can do when we have a calendar view like this is we can see whether that happened during a weekday, a weekend, which months it happened into, so we can have seasonality, and we can decide, whether or not it happened relative to some events. And so the events that are shown here is red goes off wing, green comes back on wing. And so now what we're doing is we're able to understand the relationship between parameters and various kinds of events. And then what we can do from there is we can take one of those times, one of those signatures, and we can go put it into a search tool. And again, these are very lightweight versions of tools, much more sophisticated tools that need to be built out. But what we're doing is just showing this is how people can work. The idea of this system is not to say this is the version of how people should work or how it has to work. It's how people could be working. And so then once you get that, you can click on that, and then you can see that signature using some mathematical tools, whatever mathematical tools that the subject matter experts find to be the most correct, and they can pick up different ways of looking at signatures over time, so then they can pick that signature and see where it appears over time. So what we're doing is we're starting to create a loop here, a feedback loop, where the person has analytic results, they go through understanding various aspects about it, and then that feeds back into new analytic results where I can say, hey, it told me that that signature is appearing this time, now I need to go research that. That's the new direction that I'm going to go into. Now, you could take this kind of generic idea of a system for rapid data forensics and you could use it for any kind of business. You could use it for locomotives, you could use it for turbines or anything like that. You would just put in different views depending on what kind of directions the business knows they need to research whenever a problem comes in. Now, the other thing about this system which is different is that it's all built on something called ICViz, which is Interactive Collaborative Visualization. It's all web-based. And so anything that I'm seeing on these screens is actually can appear on other screens somewhere else and be interacted with another team at the same time, even if it's remote somewhere far away from here. And so the idea is with that is that all of this visualization stuff should be collaborative analytics where people are actually working together, whether or not they're remote or local, learning and understanding about the problem at the same time. So once you have something like that, one of the other views you might want is something like what you see over here on the left-hand side. And what this is, we call this the timeline. And what's special about this is that this shows very long periods of time that something's been operating at. And so in this case, for these engines, that's up to 7,000 cycles. For some of the engines that GE has, like CFM engines, they have 70,000 cycles, and this could accommodate it. The way that it accommodates it is what we do is we bucket the data. And what we mean by bucketing the data is that we go in here, and for each pixel on the screen, it's actually showing in the background, it's calling 10 cycles worth of data. So a cycle is each time the engine's turned on and off. And so each line in here represents a time that the engine was turned on and off, that we have captured data. The gray ones are where we didn't capture data, but we expected it. So another nice thing about this particular visualization is not only does it show us the data that we do have, it tells us a lot about the data that we don't have. So in that sense, what this allows us to do is some cool tools. Again, thinking about this, right now this is for engines, but you could actually see this being used for any kind of asset. What you might do is you could have, again, locomotives or other things in here, and it'll help people understand how those things performed over long periods of times. And one of the ways you might look at that is you might go in and say, hey, you know, how well did it perform after, let's say, a water wash? And so water washes are when they blow water through the engines to be able to clean out the crud so that they perform better again. And now we can see how often each of these engines had it. You can see some interesting patterns here where this engine had it, you know, at a fairly even pace, but this one didn't have it for a long period of time and then started having it, you know, fairly frequently. Now the next thing we might want to do is say, well, we want to align on some particular aspect of it. So I might say first water wash, and now we can see the amount of time before each of those engines got its first water wash. And again, the idea, this is a general purpose solution. There may be other things you look at for other assets. It's just the idea in this particular case, this is the data that we have. Again, being pulled from the data lake, showing hundreds of engines at a time. What we're doing is showing here in the particular, how did this engine perform before and after that? And so the thing I should have said earlier in this one is, the way you read the colors is darker blue is better, white is not great, and red is bad. And so what you're looking for is, you'd hope is the engines are running dark blue all the time, but of course they're not because they're getting used, so they tend to go from dark blue toward a lighter blue. And if they're not doing that, then that's a whole other thing that you want to go looking at and you have questions about. One of the things that kind of gets a little weird in this one that somebody might ask about, though, they'll say, well, that doesn't look like it's always true, or you're seeing weird things like this. What this doesn't take into account is when engines are refurbished. It doesn't know about that, and so sometimes you'll get these changes in color that aren't what you expect. One of the things that would have to be done to this is to actually add events on when certain kinds of work was done to them and how that affected the parameters and how they go. Not what you talk about unless somebody asks. So then what you can do is, the other thing you can do with this is that you can actually look at some things like the maximum. So when you show the maximum, that's when look at within each of those buckets, when is the best cycles. Not as interesting as minimum. When you pick the minimum, it shows you all the worst buckets in each of the engines. And so you can see how badly any of these engines were doing at any given time. There's other tools in here. One of them is you can actually go look at this one. What this allows you to do is set where the thresholds are. So for different parameters, there's different thresholds. This allows the user to set them So that can be of interest, and then you can set the colors here, but we're not going to do that because that's not really needed for this demo. I would usually don't get into that dialogue for the demos. That's just for the heck of it. Usually for this one, I mean, it's pretty short and I'm done at the point where I've said here's how you can look at how events line up before and after that, and the idea of this system is it would get integrated with other systems where you might be learning additional information, and that this helps you make some kind of, again, hypothesis, or helps you understand a direction you ought to go in your research for whatever problem you have.
Okay, I've been keeping silent because we were doing the demo.